converting polar coordinates to rectangular coordinates. All right, so now we're going to look at the problems where we're given an ordered pair with polar coordinates and we want to find that same point using rectangular coordinates. How would I do that? Well, let's first kind of draw our picture one more time here. So we have some point P, and in rectangular coordinates, we want to picture that as being x comma y. Okay. And the terminal side of some angle theta passes through point P, and often call that angle theta. And then the distance the distance P is from the origin, right, at some length, and we want to call that R. All right, so now I have x, y, r, and theta all in the same picture. Well, what this reminds me of is the generalized definition of trigonometry. Gave us some definitions for sine and cosine when they are not on the unit circle. So when we are on some circle of radius r. So kind of picture this r here, or this point here on some circle here. Okay, with radius r. That is a very good circle. So what's that going to do? Well, so what are we doing here? We are doing polar coordinates to rectangular coordinates. So what does the generalized definition of trigonometry functions tell us? Well, we have the sine of theta is y over r, and the cosine of theta equals x over r. And I can solve this for y. I get y equals r sine theta, and x equals r times cosine theta. So again, if I'm going from polar to rectangular coordinates, what I have, right, I'm assuming I have r and theta, and I'm plugging those in to get y, and I'm plugging those in here to get x. And just as a review, if I have rectangular coordinates and I'm going to polar coordinates, okay, then I usually use r squared equals x squared plus y squared. And then I can solve that for r. And then I know that tangent of theta is y over x. And then I can use inverse tan and then thinking about which quadrant I'm in to go that way. So this is how we're going to go back and forth between these. All right. So example, the following ordered pairs are given in polar coordinates. Convert to rectangular coordinates and graph to check your work. Okay, so let's start by graphing. This is 3, 5 pi over 6. So 5 pi over 6 lives over here. That's the terminal side, and I want to go out 3. All right, so here's 1, 2, 3. So this is the point that I now want to think about what would be the x and y coordinates. So what I'm really thinking about is I need to go some amount left and then some amount up, right? So it'd be my x and y. All right, so I'll start with my x. I know that x is r times cosine of theta. Well, r is 3 and theta is 5 pi over 6, so I get 3 times the cosine of 5 pi over 6, right? Well, 5 pi over 6 is, cosine of 5 pi over 6 is negative root 3 over 2. So this gives me negative 3 root 3 over 2. Okay, let's do my y now. Y is 3 sine of 5 pi over 6, which is 3 times a half, which is 1.5. So if I am looking now, again, my goal is convert to rectangular coordinates. So this is negative 3 root 3 over 2, comma. 1.5. This is looking good for being in quadrant 2 because I have a negative x value and a positive y value. Let's look at what is negative 3 root 3 divided by 2, because I want to approximate this. So what is this going to be approximately? Negative 2.6 comma 1.5. All right, let's try to graph that and make sure. So that would be going left, negative 2.6. Okay, here's negative 1, negative 2, and then over, let's see, that would be 3, so about right there. That looks good. And then up 1.5. Well, here's 1, and then here's 1.5 would be over there. So yeah, that looks pretty good. All right, part B, the point, negative 2, 5 pi over 4. So first, I'm just going to plot it in regular polar coordinates. Oh, tricky one. R is negative. Okay, so remember, you're a weird cat. You've always wanted to be a weird cat. Here's your chance. You're starting at the origin. You look at this and you go, I can't do it. I gotta go. You head back the other direction. How far do you head back? 2 units. So 2 units would put us out to the concentric circle marked with 2's. Okay, so our point is living down here in quadrant 3, despite the terminal side of pi over 4 living in quadrant 1. Okay, so how would I turn this into rectangular coordinates? Well, x is our cosine of theta, and r is negative 2. Theta is pi over 4. So this is negative 2 times the cosine of pi over 4. That gives me negative 2 times root 2 over 2, which is negative root 2. Okay, a negative x value seems correct for quadrant 3, so I'm maybe on the right track here. Y is our sine of theta. That's going to be negative 2 sine of pi over 4, which is negative 2 root 2 over 2, which is just negative root 2. And that seems right. I'm on that main diagonal, and so my x and y value should be the same. I can try it out, right? We can remind ourselves that root 2 is about 1.4, and so did I go left 1.4 units and then down 1.4 units? Let's see. Let's see, this would be over about 1.4 here, and then down 1.4 is about here. I'll take it.